Welcome to Burris Agronomy U. This is Matt Montgomery, sales agronomist, and I want to take a little time to talk about corn borer today. European corn borer made quite an appearance in some non-GMO areas in 2013. In fact, I was called out to a few different non-traded fields that looked a lot like this. The yield losses were dramatic, in some cases nearing a 60 to 70 bushel yield hit. Now, non-GMO corn makes up a lot of sales here at Burris. We still sell to a lot of clients interested in those markets. So pictures like this become pretty disturbing. This is a corn borer pupa. The picture was taken by one of our Burris dealers, David Schutz, during a field visit he made to a client. When I started in the industry nearly 20 years ago, this kind of picture was not all that uncommon to find. However, finding pupa, larva, and tunneling became pretty rare over the last 15 years. Stumbling across stalks that looked like this also became pretty disturbing. It's a little hard to see it, but this stalk had 3 to 4 borer within it at one time. The dark regions are regions that this moth larva tunneled out of the stalk. And stumbling across this kind of feeding, along with other observations, like we said earlier, really caught people's attention in 2013. The past growing season did something that hasn't been done for several years. It brought European corn borer into fields at a level that made them a real topic, and for some, even a very real concern. And this leaves us with some questions. We noticed corn borer pretty easily this last year. And does that mean that corn borers are bouncing back? And at one point we said we decimated them. So is that really even correct? What does this mean also for that ever-present problem of resistance development? Is there any concern on the horizon there? So if you've tuned in to Burris Agronomy U for any period of time, you know we try to answer those kind of questions by going back to the life cycle. Understanding the life cycle is critical to all these kind of things. Well, let's take a second to remind ourselves what the life cycle of the European corn borer looks like. We used to talk about this pest having 2 generations per year. Now, it might be better to say now that there are actually many flushes of corn borer per season. 2 generations still occur, but they tend to occur at different times and in a way that mixes with a single generation version, such that we kind of keep seeing this pest for the rest of the growing season once it appears. Generation 1 overwinters as larvae. Right now in fields there are probably some larvae waiting for the spring. Once temperatures get a little more warm, those larvae will pupate, and within about 2 weeks they will emerge, once it warms up, as adult moths. So during the early summer, we will see moths, and those moths actually started out as larvae that are in the field right now. Larvae that started the previous fall and stuck around for the winter in stalks. The moths lay a couple dozen eggs on the most mature corn. There's a reason for this. We're not going to get into that today, though. Those eggs hatch, and the small larvae begin to chew holes through the leaves of the corn plant. You can see those holes as the leaves emerge, usually in a line running across the leaf as the leaf unfurls, and those holes are usually accompanied by some wet sawdust-like material that we call frass. That's a polite term for insect manure. Now, these larvae that formed in season will feed, pupate, and emerge as adult moths, and they'll lay eggs for the second generation of corn borer. They usually are attacking the plant after it is more than head tall, and usually when the silks have begun to emerge. The egg masses that are laid hatch, the larvae begin to feed on pollen and on leaves, and the resulting larvae burrow into the stalk, the ear, the shank, or the cob. Those larvae will stick around after harvest and will create problems in the next year's corn crop. Well, we covered some basics on the European corn borer's life cycle, but let's get back to those questions we put on the table and try to answer those. Let's get back to the topic of what happened in 2013. Our own scouting tours and reports from our regional sales managers, RSMs, began to indicate that corn borer was easier to find than normal. in 2013. In July, when we conducted our annual rootworm survey, we were concerned enough that we asked our summer interns to also note evidence of European corn borer feeding. The results that we got began to quantify what we had seen in the field and what our RSMs had reported. 18% of examined fields showed some evidence of corn borer, at least some preliminary feeding. And harvest reports further supported the notion that corn borer was easier to find. So let's get some perspective. Is corn borer getting worse? Now this is a zone map. It's a map used by Burris during our product selection deliberations. Each year, Burris RSMs evaluate fields for the presence of corn borer as they take plots out. They examine non-GMO or non-traded hybrids and rate the intensity of infestations there. The map summarizes our observations over the last 4 years for moderate and severe infestations of corn borer. As you can see, it's not been uncommon to find moderate to severe corn borer infestations, in particular in northwest Missouri. 37% of sampled fields have displayed moderate to severe corn borer infestations during the last 4 years. And that begins to answer one of the questions we asked: is it getting worse? As you can see, it really hasn't been uncommon to run into moderate to severe infestations on about the same percentage of the crop as what we spotted in our annual survey. Let's get some more perspective though. Let's begin to answer some of those other questions. Do we have evidence of corn borer resistance development, and did we really ever decimate corn borers? We're going to answer this by relying heavily on data from the University of Illinois. It provides us that perspective. As you can see, the University of Illinois, my former employer, conducted a fall corn borer survey starting in 1943. And that survey was discontinued just a couple years ago. I've mapped out what happened to corn borer levels from one year to the next, and I have also included a regression line, a line of best fit, to see if there's any relationship between the year and the corn borer level. In other words, I'm trying to find out if we saw any relationship between years after the pest arrived and the infestation level that we observed. Now, in regression, if you have a flat line, there's basically no relationship. And frankly, the line you see in that graph is pretty flat. From 1943 to 1995, there was no relationship between the year and the corn borer level that you observed. Corn borer levels could literally go anywhere from one year to the next. There was no relationship. You could not predict what was going to happen. Now, I want you to see what happened after 1995. In 1996, that story changed. There was still some upward and downward fluctuation in corn borer counts. You can see that here. But there was a definite downward trend. The line was not very flat. There was a significant relationship between the year, how many years you moved away from 1995, and the level of infestation. After 1995, as you moved from season to season, you could count on corn borer counts dropping in the fall survey. It all came down to the adoption, as we all know, of Bt corn. Now, as you can see in this graph, once adoption of Bt corn hit 30%, the corn borer numbers plummeted. In fact, those numbers came so close to zero that the U of I discontinued its fall survey. Some university professionals and some other professionals in the industry even went so far as to say that we had decimated corn borer with Bt. So again, there's been this recent uptick in corn borer observations in 2013. Is there any survey information that can give us some more recent perspective on those two questions we were asking? Well, luckily, Burris did not discontinue its fall survey. We continued to conduct our fall survey and have done so again this last season. The bar graph that you see here tells a very interesting tale. In 2008 and 2009, we did see a decrease in moderate to severe corn borer infestations. And that decrease almost seems to match what the U of I observed in its data set. And if you looked at 2008 and 2009 on their own, you would think that corn borer really was on its way to zero. However, that trend did not continue in 2010. And since 2011, we have never encountered less than 12% moderate to severe corn borer infestations in our fall survey. Corn borer has been hurt by the use of BT, but it has reached a new equilibrium point. It is not out for the count because of BT. So the take-home message is this. First, we can expect occasional flare-ups like we did in 2013 throughout the territory here and there. Corn borer is not done, and we will occasionally run into seasons where corn borer is pretty easy to find. That's point number 2. Third, people in Missouri can still expect that if anyone will notice higher infestations, it will probably be them. Corn borer, as noted in point 4, will also sometimes devastate late-planted non-GMO corn, and it's therefore essential that growers scout their fields. We'll discuss a little bit more about that in a second. And finally, we should all recognize that even though we don't necessarily see evidence of resistance development, a sudden spike in corn borer numbers, when resistance development does occur, when resistance develops to corn borer traits, corn borers will rapidly move back to their number 1 position as a pest alongside corn rootworm. Corn borers will not work their way from the bottom up. We'll close the session with a scouting primer. When scouting for first-generation corn borer, you're looking at 20 plants in each of 5 locations throughout the field, and you are looking for that whorl feeding we described earlier, holes and lines across the leaves of the plant. At each stop, you will dissect the plant and count the number of borers. A worksheet then helps you estimate what the infestation level looks like in the field and can help you then pencil out where an insecticide may yield a return on investment. You're looking for larvae and whorl feeding with Generation 1. You're not looking for egg masses. That worksheet that we described to you earlier is right here. A brief Google search should get you there. This is a copy of the worksheet from U of I Extension. The procedure for looking out for Generation 2 involves looking at 50 random plants scattered in the field, and you're looking at the midrib of leaves in that midsection of the plant, recording the number of egg masses that you find. You're counting the pushpin head-sized egg masses. You're not counting the larvae to determine whether or not you need to treat. As with Generation 1, we again have a worksheet that you use to determine if the number of egg masses indicate that the population needs to be managed. It can be reviewed online following a brief Google search. So corn borer was easier to find in 2013, although previous information seems to indicate it was disappearing from Midwest agriculture. That really does not appear to be the case. And while we don't have indications that resistance has developed, we can say that corn borers appear really healthy and have survived the advent of BT corn rather well. For more information about pest management or other agronomic topics, contact your local Burris RSM and stay tuned for more information from Burris Agronomy U.